Welcome to Module 6, Automation, Web Data, and Performance. In these 6 lessons, we will bridge the gap between running Python code on your local machine and interacting with real-world services and data. We will cover APIs, web scraping, email automation, and performance optimization using threads, processes, and asynchronous programming. Here is our roadmap. We start by connecting to web APIs and scraping websites. Next, we will automate email sending. Finally, we tackle performance, using multi-threading for I/O-bound tasks, multi-processing for parallel computation, and asyncio for high-efficiency task management. Each lesson includes practical projects to build your skills. Lesson 1 focuses on working with APIs. APIs allow software to communicate over the internet. Instead of building features from scratch, you can integrate services for data like weather, stocks, or movies. We will use the request library to send requests and interpret the returned data. An API, or application programming interface, is how applications exchange information. Your code sends a request and receives a response, usually in JSON format. JSON is structured as keys and values, which Python naturally interprets as a dictionary, making it easy to access the information you need. To get started, install the request library using "pip install requests." In your code, import the library, define your target URL, and use requests.get to fetch data. Calling the .json method on the response object converts the raw web data into a standard Python object for you to use. Always verify your request status before processing data. A status code of 200 confirms success. Codes like 404 or 500 indicate errors. Always include a check for the status code in your scripts. This simple practice prevents your program from crashing when it encounters unexpected server responses. Navigating JSON data depends on its structure. If the data is a list, loop through it. If it is a dictionary, access values by their keys. If the structure is nested, simply chain the keys. Just match your access pattern to the structure of the data returned by the API. APIs allow for data transmission too, using the POST method. You can build a dictionary and pass it as the JSON parameter to request.post. As with reading, always wrap these actions in error checks to ensure your requests are successful before moving on. In this example, we fetch live weather data. Notice how concise the code is. Remember these best practices. Keep keys secure, do not overload APIs with excessive requests, and always read the official documentation. Being a responsible API user ensures your code stays reliable. For your project, try building a movie information tool using the OMDB API. You will handle user input, make requests, and display formatted results. This exercise will cement your understanding of parameters, JSON parsing, and basic error handling. Lesson 2 covers web scraping. When a website doesn't offer an API, you can collect data directly from its HTML. We use the requests library to download the page, and Beautiful Soup to parse the structure and extract exactly the information we need. Web scraping follows a clear flow. Request the page, retrieve the HTML content, parse it with Beautiful Soup, locate the specific elements, and finally extract and clean the data. Remember, Beautiful Soup parses, but it does not download content. You must pair it with requests to fetch the web pages. To start scraping, import requests and Beautiful Soup. After fetching the HTML with requests, pass the response text to a new Beautiful Soup object. You can then easily access elements like the page title using soup.title. The .text property is your go-to for extracting readable text from HTML tags. Use the find method for the first matching element, or find_all for a list of all matches. You can further narrow your search by class or ID attributes. For those who know CSS, the select method allows for even more flexible and concise querying of web page elements. When extracting links, use link.get to safely access the href attribute. When dealing with web text, apply the strip method to clean up extra white space. Finally, for lists of data like product cards, use a nested finding approach. Find the container, then search for details within it. Robust scraping requires handling common issues. Sites may block automated requests, so using a user agent header is essential. Always verify if an element exists before attempting to access its text, and be aware that content loaded by JavaScript won't appear in the initial HTML response. Finally, add delays to avoid overwhelming servers and getting your IP blocked. Once you have collected your data, persist it. Python makes it straightforward to dump structured data to JSON or write records to a CSV file. Remember to always scrape ethically. Review the site's robots.txt, respect its terms of use, and never collect private data without consent. Responsible scraping protects everyone involved. Let's put it together with our mini project, a news headline scraper. This script fetches a page with a browser header, confirms success, parses the headline elements, cleans the text, and writes each one as a row to a CSV file. It is a complete pipeline for moving data from the web to your local storage. Lesson 3 covers sending emails with Python. This is a powerful automation tool for notifications, reports, or reminders. We will use the built-in SMTP-LIB and email message modules to construct and send messages over SMTP, including plain text, HTML, and attachments, all while maintaining secure practices. Sending email via SMTP involves connecting to a server, logging in, and transmitting a message. The SMTP-LIB module handles the connection and the actual sending, while the email message module helps you structure the content correctly. With a standard subject, sender, and recipient format, you can reliably deliver automated messages. Security is vital. Never hardcode your main account password in a script. Use app passwords provided by your email service and store your credentials in environment variables. Always secure your connection using star2DLs to keep your login data protected during transmission to the server. You can make your emails more engaging by sending formatted HTML. It is best practice to include a plain text version as a fallback for clients that may not support HTML rendering. Additionally, attaching files, like PDFs or reports, is simple using binary mode and the add attachment method on your message object. Make your email automation reliable by wrapping your code in try-except blocks. This ensures your script handles errors, like authentication failures or network drops, gracefully rather than crashing. Our contact form project demonstrates this by taking user input and safely delivering it to your inbox using a standard SMTP server. Lesson 4 focuses on multi-threading. This allows you to run multiple tasks concurrently, which is ideal when your program spends most of its time waiting on external factors like network responses, file system operations, or database queries. You will learn to manage threads and utilize them to speed up your automation. It is important to understand the Global Interpreter Lock, or GIL. It means only one thread can execute Python code at once, so threading won't speed up CPU-intensive math. However, for I/O-bound tasks that are mostly waiting, threading is a game changer, allowing one thread to work while others wait. Creating a thread is straightforward. You define a target function, initialize a thread, and call start. Using join ensures your main program waits for the thread to complete before moving forward. Remember to pass a trailing comma when supplying a single argument to your thread, ensuring it remains a tuple. When multiple threads access the same data, you risk race conditions. This is where you use a lock. By wrapping your shared data access in a with lock block, you ensure only one thread can modify the data at a time, preventing errors and ensuring your program produces consistent, correct results. The cleanest way to manage multiple threads is with the thread pool executor. This tool allows you to specify a fixed number of workers and map functions over data, or submit individual tasks. It takes care of thread management automatically, provides result handling, and simplifies your concurrent code significantly. In this project, we build a multi-threaded URL status checker. By checking many websites concurrently, we can dramatically reduce the total time required to get their status codes. This project reinforces the power of threads for I/O-bound tasks and demonstrates the practical benefits of the thread pool executor. Lesson 5 explores multiprocessing. Unlike threads, which share the same memory, processes run in parallel on different CPU cores. This bypasses the GIL, making multiprocessing the right choice for heavy computation tasks that require genuine parallel performance for things like image processing or large-scale data analysis. Let's compare our performance tools. Threading is best for I/O-bound tasks, while multiprocessing is ideal for CPU-bound work. Multiprocessing bypasses the global interpreter lock by using separate processes, each with its own memory and interpreter. This makes it perfect for heavy calculations, large data processing, or image manipulation. Creating processes is similar to threads. Define a target, pass arguments, start, and join. Crucially, always guard your main code with an if __name == main block. This prevents infinite process creation, especially on Windows, and ensures your process logic only executes when intended. Since processes do not share memory, you need specific tools to pass data back. A queue can move results between processes safely. Alternatively, multiprocessing.pool provides a cleaner interface to map tasks across a pool of workers, gathering results automatically. It's the standard choice for most parallel workloads. In our parallel file processor project, we use a process pool to count words across many files simultaneously. By distributing the work, we utilize all CPU cores, significantly reducing total runtime. Remember, keep worker counts near your core count and avoid moving massive amounts of data between processes to maintain efficiency. Lesson 6 introduces Async I/O. This modern approach handles high concurrency tasks with a single thread. Instead of waiting for one task to finish, Python switches to another idle task, It is ideal for I/O-heavy operations like calling multiple APIs, scraping, or maintaining active network connections. Think of async like cooking. Instead of waiting for the pasta to boil before starting the sauce, you start both tasks and check on each as it finishes. In Python, use async def for coroutines and await to pause non-blocking tasks. Just remember, async is for waiting, not CPU-heavy work. To run tasks concurrently, use async.cio.gather, which launches multiple tasks and collects their results together. If you need to start a task now and await it later, use create_task. Because await only pauses the current task, the event loop remains free to run other operations, providing massive scalability. Production async code must be robust. Use wait_for to set timeouts so tasks don't hang, and return_exceptions in gather to ensure one failure doesn't crash everything. Finally, limit concurrency with a semaphore, and remember to use "TTP" rather than the standard request library to avoid blocking the event loop. Our final project is an async website status checker. It uses a session to manage multiple concurrent requests efficiently. By combining "async_gather" and a semaphore, we check dozens of sites in parallel while maintaining control. It's a perfect example of how lightweight and fast async Python can be. Wrapping up, choose your tool based on the bottleneck. If you are waiting, use async I/O for high concurrency or threading for simplicity. If you are computing, use multiprocessing. Match the tool to the problem to ensure your code is both fast and efficient. Congratulations on completing Module 6. You now have the skills to connect Python to the real world, from APIs and scraping to complex automation and high-performance concurrency. Use these tools to build powerful, connected applications. Keep building and keep learning.